Hello, welcome to Algebra 2. Here we're doing Chapter 7, Section 3. Here in 2013, we're keeping it fresh. We're switching up the section order a little bit. We're going to go back and do Section 3 after having talked about Section 4 with its logarithms for a couple of days. This is because Section 3 introduces this new idea called E. E is an amazing number. You might have thought it was a letter. It's actually a number. It's quite possibly the fourth most important number after 0 and 1 and pi. It's exciting stuff. You really want to give yourself a chance to learn all the awesomeness of E. So go ahead and read the beginning here, and then there, and then the first couple examples. And I'll wait so you can pause the video, and when you come back after reading that, I'll still be here. Hey, welcome back. So here we've got a couple example exponential functions. You got some x's, you got some y's, it's got y equals, you got x in the exponent. It's good stuff. And the question is, are these exponential growth functions or are these exponential decay functions? Now remember, normally back when the base wasn't e, you would just tell by looking at the base, and you'd say, hey, is the base more than 1? It grows. Is the base less than 1? It decays. But here, well, the base is always e, and the trick is what's going on as the coefficient of x, that's the number multiplied by x, in the exponent. Let's look at this first one. All right, so the key thing is that 4x. Now, 4 is more than 0. It's positive. So it's exponential growth. And that's all there is to this type of problem. Just identifying if it's growing or decaying. All right, look at the next one. This one looks a little more complicated. But the main action is still that negative x over 3. But it's written tricky style. You'll need to separate out the fraction piece. Basically shove the shove the x off of the fraction. So you have negative 1/3 times x. Okay, now, negative 1/3, that's less than 0. It's negative. So, exponential decay. That's it. These are not the hardest problems ever. They might be a little strange to look at, but there's not a lot of work involved. Now, if you look ahead, we got some issues on how to graph exponential functions with base e. So, you can go through the description, this just excellent example, and then go ahead and I'll pause the video and go read that example, and I'll wait for you. I'll be here when you get back. Hey, welcome back. That was a good example, wasn't it? One of the best, I tell you. Okay, now, let's look at this equation. We got e to the negative 1.5x. It ends with plus 1. So we're talking about a scenario where, because of negative 1.5x, it's going to be a decay graph. Now, I highlighted that at first because it's the very last thing we were just doing on the other problems, but it's actually not going to come into play right away. At first, we're going to play the normal exponential function game. So, see, first of all, boom, plus 1. It moves up 1. So the asymptote, which is a horizontal line for exponential graphs, is at y equals 1. So, there you go. Horizontal asymptote. Awesome. Okay, now, next step for me here, and hopefully for you, is figuring out what's going on with that y-intercept. So, the y-intercept, quick reminder, is when x equals 0. So, we'll go ahead and rewrite the equation with 0 in for x. Good stuff. Notice up in the exponent we have negative 1.5 times 0. That's really just 0. So it becomes e to the 0 plus 1. E to the 0 is 1. This is a huge deal. This is because anything to the 0 power is 1. Except for 0 to the 0, but we don't speak of it. So we got 1 plus 1, 2. So the y-intercept is 0, 2. Not so terrible, really. A little scary looking with the e, but in the end, poof, not that exciting. So 0, 2, put the dot down, and then swoop your way down to happiness. Now I said down this time because it's exponential decay. Because of the negative 1.5x. All right, now we've made the graph. The domain is all reals because it goes left forever and it goes right forever. The range is all the numbers above the asymptote, so all the numbers greater than 1. Awesome. Okay, now look at the next one. We got y equals 2e to the 2x minus 4. All right, good stuff. Now, here, the 2x up there in that exponent, because it's a positive 2, it's going to be growth. Again, I highlighted it first because it was a big deal in the first part of the notes. If it's not the first thing you notice, not a big deal, as long as you notice it eventually. Okay, so because of the because of the minus 4, it goes down 4. So y equals negative 4 is the horizontal asymptote. Horizontal asymptote at negative 4. Good stuff. Next up, looking for our y-intercept. This y-intercept, like every y-intercept ever, is when x equals 0. Go ahead and write in 0 for x. 2 times 0 is 0, up in the exponent. E to the 0 is 1. Now remember that 2 in front doesn't have that exponent action. It's 2 times e to the exponent thing. So it's 2 times 1, minus 4 now, and that's negative 2. Y-intercept, 0, negative 2. Dot it up, and then swoop your way up into happiness. This is a swoop up because it's exponential growth, so as you move to the right, it grows super big, super tall, super fast. All right, domain and range. Domain goes left forever, right forever, all real numbers. Range, all the numbers above the asymptote. So y is greater than negative 4. Awesomeness. We're halfway done. Okay, now, this stuff about natural log, let me tell you, it's pretty awesome. So, I'd like, again, to encourage you to read through the introductory explanation, which is, frankly, amazing. Example 5, which is, well, exemplary. And then, I'll wait a few seconds. You can pause the video. I promise to come back and talk to you about this stuff here. Hey, welcome back. So we got some inverse functions to do. This is exactly like in the notes last class. We're going to pull the switcheroo. We're going to solve for y all over again. So, switcheroo first. Where there was a y, there's an x. Where there was an x, there's a y. Now, y, instead of being off on the side, is now up in an exponent. But first, that minus 1 has got to be tamed. That's not so bad, really. Just add 1 to each side. And now you get up here. Y is in the exponent. Nothing else to do except change the form. Remember, anytime you're doing an exponential equation and an inverse, you're going to change it into a logarithm equation. So, it's log base e, and then x plus 1 equals y plus 3. Remember, this changing form business into logarithm kind of switches the order of the pieces of the equation. It's very tricky for people to understand, but I'm pretty sure you'll get it. Okay, so we're almost done, because now y is a free soul over there on the right. It does have this plus 3 hanger on, so get rid of that by making it subtract 3 from each side. You're done, except, well, you think you're done. If you want good style points, go ahead and rewrite it as ln instead of loggy. This is the correct way of writing it in the box. You know, for me, if you wrote it the version above where it said log base e, that would still be correct, but not as good. Okay, over on the right, we've got y equals ln x minus 1 plus 2. So y equals the natural log of x minus 1 plus 2. Now, like I wrote in the notes before, anytime you see natural log, I strongly recommend you rewrite it where it says log base e. And if that means just scribbling out the ln and writing log base e near it, or rewriting the whole thing, either way, I really recommend you give yourself this visual cue here. All right, Now, switcheroo time. X's and Y's flippity floppity. All right, now Y is inside the logarithm. This is a problem, but really we can avoid the problem for a minute by getting rid of that 2. And really, we need to do that first. Now we have nothing else to do. It's in logarithmic form, but the Y is in the logarithm. That means we need to switch it into exponential form. So, e to the x minus 2 equals y minus 1. So this swippity-swappity of the forms. Remember, anytime it starts in a logarithm, you're doing an inverse, you're going to need to turn it into exponential form. All right, so not quite done. Got to add the 1. That's pretty boring. Boom, boom, boom. Done. All right, so we got some more issues on graphing. Got this example 6, which is frankly par excellence. I mean, it's amazing. So I'll let you go ahead and read example 6. I'll pause a few seconds so you can pause the video here. When you're done reading example 6, I promise I'll still be here. Hey, welcome back. So here we have this y equals natural log of x plus 3, meaning x plus 3 is all inside the natural log. Hopefully you notice the plus 3 inside the log means it's going to move left 3. This is like every other graph we've ever made. So, the asymptote, remember it's normally a vertical asymptote at 0, moves left 3. So, there you go. Now, this x-intercept business is serious business. It's going to take some work. To do an x-intercept, that means y equals 0. This is always true of any intercept. The other variable has to be 0. So, that means 0 equals natural log x plus 3. Now that we're getting serious about the natural log, I continue to recommend that you rewrite it as log base e. And now to move forward, you need to trade it into exponential form. So e to the 0 equals x plus 3. That's wonderful. E to the 0 is 1. So 1 equals x plus 3. Subtract the 3. You get x equals negative 2. You've got yourself an x-intercept. Boom. And then you got a dot. Now the good news is for us, all of our log graphs have the same general shape, so you can swoop your way on up. The domain here is going to be x is greater than negative 3. The range is going to be all reals because they do go up and down forever. They go up very slowly, but they do go up forever. Just very slowly. We're done here. We're almost done with the notes. Only thing left is this last one. Excuse me, I got excited here. I went ahead and I noticed that it went up 3. Notice the plus 3 is not in parentheses, so that plus 3 is not inside the logarithm, so it's added on the outside. That shifts the graph up 3. So the asymptote, which is a vertical line, doesn't change. Vertical shifts don't change vertical lines. They kind of go forever up and down either way. So, asymptote's still at 0. There's that dashed line of close happiness. Then go ahead and start looking for that x-intercept. Now, x-intercept, like always, makes the other variable, in this case y 0. So 0 equals natural log x plus 3. We're still getting our feet here, so I recommend we rewrite natural log as log base e. Move the 3 over, because the 3 isn't really part of the logarithm problem. Now you're stuck changing to exponential form, so negative 3 equals x. Now, excuse me, e to the negative 3 equals x. Now, e to the negative 3 is not a pleasant number to think about. It's actually really, really tiny. It's about 0.05. It's actually closer to 0 than it is even 0.1, but it's not on 0 exactly, so I put 0.5. So anyway, the x-intercept is 0.05, comma 0. The point is that it's a dot just over to the right. My dot is not perfectly accurate. There are limitations on how awesomely I can draw by hand, but it's right next to the asymptote. Swoop your way on up. The domain is all the numbers to the right of the asymptote, just like always for any logarithm graph. And the range is all real numbers. Boom, chicka boom, we are done. We have finished these notes. We now have mastered E. I've got an assignment for you to try. It's pretty awesome. I hope you enjoy it. Hey, thanks for watching, and please let me know if you have any questions.